Alright, in 5.7 we are talking about transformations of polynomial functions. We have discussed transformations of functions a couple of times already, so none of this should be anything new. Let's just do a quick review over all of these. Yes, I do want you to write down this whole page. You still need to write down everything here. So transformations of polynomial functions, remember, if you have a horizontal translation, it will show up as f of x minus h inside the parentheses. A minus will be to the right. A plus will be to the left. Your vertical translation will be f of x and then plus k on the end. Plus moves up, minus moves down. In your reflections, if you have a negative on the inside, f of negative x, it's a reflection over the y-axis. A negative multiplied in front on the outside, negative f of x is a reflection over the x-axis. Now, you have a horizontal stretch or shrink. It's multiplied by a on the inside, so f times a, or f of a of x. F of a times x. So if you have 2 in the inside, it is a horizontal shrink by a factor of 1/2. If you have 1/2 on the inside, it is a horizontal stretch by a factor of 2. You've written all of this before, but for your shrink, remember that your a value is greater than 1. And for your stretch, remember that your a value is between 0 and 1. And that's on the horizontal. Now, for the vertical stretch or shrink, your a is multiplied out front. And if a is greater than 1, it is a, so for example, 8, it is a vertical stretch by a factor of 8. And then if you have a 1/4, so if a is between 0 and 1, you have a vertical stretch by a factor of, in this case, 1/4. So just remember the difference between your horizontal and your vertical stretches and shrinks. Horizontals are on the inside and they seem to be backwards. Verticals are on the outside and they are as is. So that being said, let's look at example 1. Describe the transformation of f of x equals x cubed represented by g of x equals x plus 5 cubed plus 2, then graph each function. So, first of all, let's look at the plus 5. That is on the inside, and it is a plus, so that is going to be a translation to the left five units. And then we have our plus 2 on the end. So we're going to put and. The plus 2 tells me it's going to go up. And it's also a translation, so I'm just going to put and up 2 units. Okay. So now let's go ahead and graph. If we're graphing the f of x, then we're going to go through 0, 0. You can put that in your calculator. F of x equals x cubed. You will go through 1, 1, and -1, -1. Then you will go through, if you have 2, 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go up something like that. It's a little off. And then we're going to go -2, -8. There we go. Now, if we are going to move left 5 units and up 2 units, then let's take that origin, the 0, 0 point, go left 5, 1, 2, 3, 4, 5, and up 1, 2. Take this point down here, left 5, up 2. This point here, left 5, up 2. This point here, left 1, 2, 3, 4, 5, up 2. Let's go ahead and draw that bottom half. And then we can move up to the top. Left 5, 1, 2, 3, 4, 5, up 2. And then we can draw the top half. So the green is my f of x function, and the red is the g of x function. There we go. Let's look at another one. Example 2 says describe the transformation represented by, if we have f of x equals x to the fourth, and then g of x equals negative 1/4 x to the fourth. So x to the fourth is not a function that it's a function we may not have seen as much before, because we've seen x, x squared, and x cubed, but we can still tell what's going on because we can look at the same stuff. So we have a negative out front right there, and then we have the 1/4 out front as well. So the negative multiplied in the front is going to be a reflection, because negatives tell us about a reflection. Being that it's in the front, it is a reflection across the x-axis. And the 1/4 in the front, there's any number multiplied in the front, tells us that it is a vertical, either stretch or shrink. 1/4 is between 0 and 1, so that is a vertical shrink. So a reflection across the x-axis and a vertical shrink. By a factor of 1/4. So now let's go and graph that. If we plug that into our calculator, then we can get a table. Plotting points for the original f of x equals x to the fourth. We have negative 2, 16, which is not exactly going to fit. Negative 1, 1, 0, 0, 1, 1. And then 2, 16, which is not exactly going to fit. So there's f of x. Then we can get our g of x function. We will have negative 2, negative 4, negative 1 will be about negative 1/4, 0, 0, positive 1, negative 1/4, positive 2, negative 4, and we can plot that, draw that graph. I missed my point, but that's okay. Alright, so there's our g of x. And there we go. We have a reflection across the x-axis, which is shown here by it flipping, and a vertical shrink by a factor of 1/4. So it is a little squished per se. And if you look at the graph on the calculator, you'll be able to see that a little better than the graph that I've drawn here. Also, as I've forgotten, don't forget to highlight your answers. Highlight the writing. You don't necessarily have to highlight the graph. If you want to put a box around the graph, then that's perfectly fine. So let's go back over here. Don't forget again to highlight your answers. And like I said, if you want to put a highlight box around the graph, that's fine. You don't have to highlight the whole graph. Okay, let's look at another one of these. We have x to the fifth and 2x to the fifth minus 3. So we have a 2 in the inside, a minus 3 on the outside, a 2 on the inside. Any number multiplied on the inside is a horizontal stretch or shrink. So this is going to be a horizontal. Since 2 is bigger than 1 and it's horizontal, it's backwards, so it's going to be a horizontal shrink by a factor of 1/2 because you flip it, and the 3 on the outside subtracted is going to move down, so we're going to say and a translation down 3 units. Alright, so now if we were to graph this original function of x to the 5th, let's put that in our calculator. The parent function, the x to the 5th, if we're looking at the table, we have -2, -32, that goes way off our graph, -1, -1, 0, 0, and 1, 1. Looking at the shape of the graph, it looks very similar to the x cubed function. Alright, so there's our f of x. And the g of x has a horizontal shrink and a translation. So if we look at its table, -2 goes to about -1027, -1 goes to -35, 0 goes to -1, 2, 3, and 1 goes to 29. So that's really, really stretched. It still has the same shape, but stretched up really high there and stretched down really low there. So there we go. There's our g of x. If you want to change your scale so that you can plot more of those points, you can. Just make sure you do it from the very beginning before you graph f of x. Alright, so here we go. Horizontal shrink by a factor of 1/2 and a translation down 3 units. And there's the graph of both functions. Alright, example 3. Let f of x equal x cubed plus x squared plus 1. Write a rule for g and then graph each function. Describe the graph of g as a transformation of the graph of f. So, right here, it says write this rule. So we have f of -x. First of all, let's go ahead and describe that, even though it doesn't say that until the end. But if we go ahead and describe that negative on the inside is a reflection across the y-axis. Okay, so a reflection across the y-axis. Now let's go ahead and plug that in. So if we're going to write a rule for this, we have our g of x equals f of -x, which they gave us here, and we have f of x here. So now all we're having to do is replace each x with -x because of the -x right there. So we have -x cubed plus -x squared plus 1. So let's go ahead and simplify that. We've got g of x this equals -x cubed is going to just be negative times x cubed. -x squared leaves it at positive x squared. And then we have our plus 1. So there's two things done, the reflection across the y-axis, and g of x equals -x cubed plus x squared plus 1. Now the last thing to do is to graph. So if we graph the original, then we have a point at 0, 1, and at 1, 3. I believe, just a second, let me check the table. Okay, so yes, 1, 3, 0, 1, negative 1, 1, negative 2, negative 3, 1, 2, 3. All right, so our graph here goes up just a little bit and then comes back down and goes up through there. Then let's redraw that left side there. That wasn't much better. Okay, now let's go ahead and draw the right side. Or, I'm sorry, not the right side, but the g of x. So g of x goes through negative 1, positive 3, 0, 1, 1, 1, and 2, negative 3. So again, it goes up just a little bit right there. And there we go. And there we go. So there's our g of x. And the green is our f of x. And it's just a reflection across the y-axis, so they are just flipped. Okay, so again, if you want to draw a box around the graph, that's perfectly fine. Just make sure your other answers are highlighted. Now then, let's look at this one as well. This one, you can graph it in your calculator, but the main part I'm worried about right here is just getting the, writing the function. So if we're starting with our f of x equals x cubed plus x squared plus 1, that 3 right there is going to be a vertical stretch. If I could spell, that would be amazing. I put an extra C in there. Sorry. Vertical stretch by a factor of 3. So g of x is going to be 3 multiplied by the entire f of x. So x cubed plus x squared plus 1. So then g of x, if I distribute that 3, I get 3x cubed plus 3x squared plus 3. So where before I had my graph, my original, that looked something like that, all I'm doing is stretching that, a vertical stretch by a factor of 3. So if you plug that into a calculator, let's get those points real quick. That would be negative 2, negative 9. It's going to be way on down there. Negative 1, 3. 0, 3. And 1, 9. So it's still going to have this hump right here that's just a little bit bigger. And that's going to go back up through there. And this is going to go down through there. So the red is your g of x, and the blue is your f of x. Vertical stretch by a factor of 3. There's the new function. Okay. Example 4. Let the graph of g be a vertical stretch by a factor of 2, followed by a translation 3 units up. So we have a vertical stretch by a factor of 2, followed by, big thing there, followed by translation 3 units up from this graph. Write a rule. So if I'm writing a rule for g, I've got to start with h because I have a followed by. So h of x is going to equal the first thing, which is a vertical stretch by a factor of 2. So I have 2 times my f of x. So let's go ahead and do that. 2 times the x to the fourth minus 2x squared. Distribute, and we get 2x to the fourth minus 4x squared. So that is our h of x. Now we just need to get our g of x. That's the second thing here, translation 3 units up. So that is just going to be h of x with our plus 3 on the end. So we're going to go ahead and write down our h of x function, which is 2x to the fourth minus 4x squared, and put that plus 3 from here on the end. So there's our g of x function. There wasn't a whole lot to that one. It was just 2 steps, so you got to make sure you get both of them. All right. That is 5.7.